Okay, so yeah, last time we were learning about functions. And the general idea for how we write our functions is it's this, right? So you say whatever you want your function name to be. Remember, oh wait, I should refresh. Did I not update this? I did not. The general idea is you pick a function name. It can be whatever you want, like a variable name. But don't make it match a variable name. If you have a variable called my function, and then a function called my function, that's a recipe for disaster. Don't do that. And then you can have however many parameters you want. If you want a function that needs 2 parameters, okay, have like 2 parameters. There I have 4, and the ... just means like however many more you want. So if you want it to have no parameters, put nothing in the parentheses. If you want it to have 2 parameters, put 2 names in the parentheses. Just like the function name, the value, like the name of the parameter you give, it's up to you. Depending on what the function is, there might be things that make sense. Like if you're calculating density, you could take like volume divided by mass, right? So maybe the parameters are volume and mass. But you can call them whatever you want. They're just like variables. And then you can have as many statements as you want. But all of the statements that you want to be a part of that function must be indented with everything else in that function. So just to make sure we're all getting up to speed, if I say like def add 2 a number, so here my function name I called it add 2. It only has one parameter, a number. Now if I want to start typing things, I'll type in here. If you start typing like this, or printx, if you do this, it's not going to be happy. Because I told Python I'm starting to define a function, and then I didn't actually put anything in that function. Because if I want the code to be a part of that function, it has to be indented. And now it's happy. If I have something like this though, well, it's going to say, well, hold on, you indented, and there's no reason for you to have been indenting. If I want to continue writing code that's not in this function, well, that's fine. Just unindent. And then we could call the function add 2 to 5, add 2 to 10, and I can run them. Cool. Remember, the first part with the def, that is the definition of the function. A lot of people in lab yesterday, and it's okay, you're getting used to this. You do this, you hit run, and you're like, well, nothing's happening. Why is nothing happening? Well, I never asked Python to do any number crunching. I never asked it to do anything. All I did was, hey, here's a function, and then we never used it. To use it, we have to call it. Like this. Cool? Now, in many other programming languages, they'll have different conventions or different syntax for how you can define what is in and what is not in a function. In a lot of popular languages, you'll see the squiggly brackets. Like, I'll show you an example. Something like this. And that would mean like, okay, start function, end function. In Python, we don't use those. We just use indentation. And there's other conventions across other programming languages. Never forget your colon. I always make fun of people when they do. I'll tease you if you forget your colon. Don't worry if you forget it. Common mistake. But I reserve the right to tease you in lab if I go, your colon. Oh. Okay, so here is an activity that if, I know people's Wi-Fi has been hilariously terrible lately, but if you are capable of going on Colab, do this activity, cat stir. See if you can figure it out. Notice that hello has a space after it. That's because I was lazy and I wanted the space to be in the concatenation. So yeah, write this function. Remember, how do you concatenate strings? The plus sign, right? So I'll give you a couple minutes to do this one, because it's a good one. And remember, if you talk to one another if you get stuck or something. During the activities, you can be noisy. If you get stuck on something too, you can raise your hand. Maybe we can help you out. What's up? What it'll do is if whenever you run something, like define a function, you hit run, Python remembers that you defined it. So even if you delete that code, it still remembers that function that you wrote. If you do restart runtime, it'll just forget everything and start over. Your code will stay, but it's like you just restarted and wrote all the code and Python's just waiting for you to do something. Sure. That might make things, nice, a little cleaner. It's not a hand up, is it? You just stretching? Okay. So I just started defining the function, but I didn't actually write anything in there yet. So if you're stuck on just getting started, maybe this will give you a hint. Raise your hand if you're done. Raise your hand if you'll be done in like 2 seconds, just one more second. Yeah, okay, keep it up, keep going. If you are done, move on to the next activity though. The next one's a good one. I like that one. Okay, if you're still stuck on this one, I'm gonna finish the cat stir and then we can do it together. And maybe if you were kind of getting stuck on something, you could see where things went wrong. Now I like to write verbose code. So I'm gonna use like a variable. So what I'm gonna wanna do is the string equals, so I want this function to be able to concatenate any two strings. In the example, I said hello space and then world, and I want it to concatenate hello and world together. But I also want it to be any arbitrary strings. This function is going to take two parameters. Think of it like f of x and y, and then what are you going to do with those x and y's? You're never asking yourself, but what's the x and the y? That only matters once we set what those values are. At this point, it's an arbitrary value. It's just a variable, the parameter. So a word plus B word, right? And this should concatenate, right? If we're ever concatenating strings, or if we ever use a plus sign with strings, that means concatenate them. So now I have the string, and then the next thing I have to do is just print out the string. Okay, so that function's defined, and I ran it, and Python now is happy with it. So if you were stuck, was there something about this that, like, what was the part that got you? Because sometimes it's really, really helpful to talk about, because chances are if you were stuck, there's like at least another dozen people. Yeah.
I'm still, I know this is stupid, but I'm still confused a little bit about cat string and all that and what it does. So this is why I try and understand it a little bit better.
Sorry, but what is the question? Sorry?
I'm just still a little bit confused about what cat stringing does and all that. And that's the word I understand what you guys do with it, but I'm still confused about how it works and when to apply it. So
For this activity, or are you on the next activity? Oh, so we defined it. We made it up.
Okay.
So I'm saying here's a function called cat stir. And what do I want it to do? Well, I'm writing what I want it to do. It's not a predefined thing. It's something we are writing right now. And all we need, so it's like what I mean is it's not like print that already exists. If I restarted my runtime and tried to call cat stir, it's not going to work because it doesn't exist. So here I hit run. And Python goes, oh, okay, you wrote a function called cat stir. Great. So now if I ever call cat stir, hello world. Wonderful. Was there anyone, like, was there something else that someone got stuck on? If you got stuck, was it a syntax thing? Be honest. That's common. Yeah. Cool. All right, so are there any questions about cat stir? All right, so everyone is 100% okay with this function in that case then, right? Yeah? Okay, so now for the good one. Now for the real tricky one. And I am going to emphasize, this one's important to understand. This one here, if you're having difficulty with this, it's fine. You're new at this. But it is going to be very important that this does make sense to you. And let me give you a hint mathematically. Where's my marking? If I gave you the function like f of x equals g of x plus 1, right? And I'm going to, based on what I gave you right there, if I ask you to tell me, okay, based on this, what is f of 3? What's f of 3? Pardon? What did you say?
What's g of x?
Exactly. You can't calculate this. There's no g of x. Like, what's g of x? It's whatever g of x of 3 is plus 1. So in order for this to make any sense, we have to have a g of x as well, which is fine. And let's say g of x equals x squared. I don't know. Right? So now, I'm confident that all of you can do this. And what we're about to do is going to be very similar in Python, just in code and not in math notation. Now if I ask you, and don't yell out the answer, I'll give you a second. Now if I ask you, what is f of 2? What did I just say? And you're wrong.
5.
What did I just say? Don't yell out the answer. Give people a shot. Look at this and get the answer and understand why that's the answer. f of x is g of x plus 1, and g of x is x squared. Raise your hand if you're like, I don't know about that. Be honest, I want to know. Or raise your hand if you are 100% A-okay with what that is. Really high, I want to see. I want to see. So I want to get a sense of whose hands aren't up. Okay, so about half the class, and that's fine. The answer to this, if I say what's f of 2, is 5. Why? Let's say it. If I say, you know what, I'm going to type it in like Notepad. If I have f, can you see this at the back, or is it too small? It's all right? Okay. So if I say f of 2, if I plug that into this expression, it's going to be g of 2 plus 1. But I can't solve this problem without knowing what g of 2 is, right? But based on this, I know g of 2 is equal to 2 squared, right? You know what? I'm going to use Python notation. If you do multiply in a row, that means square, by the way. So 2 squared is whatever that is, which is, of course, equal to 4. So now that I know what g of 2 is, I can then go back and say, well, based on that, that's also equal to 4 plus 1, which is also equal to 5. So I have two functions here. G of x, whatever, straightforward. F of x is a little funny though, because in order to solve f of x, we need to have a way to solve g of x, because f of x depends on g of x. The function f uses the function g in its calculations. Okay? So, we're going to take this idea where we have functions calling functions, and there's no limit to this. We could have functions calling functions, calling functions, calling functions. There is technically a limit, but mathematically there isn't one. We're going to use this idea. Okay, so this one's tricky. It's important. Take your time with it. I want you to write a function called crosscat that will take 4 strings. You know what? Before I even finish reading it, let's set up the function. Def, that it takes 4 strings. A word, B word, C word, and D word. Okay, I've just set it up. All I did was I didn't even hit run yet, but what I'm starting to do is to tell Python, okay, this is what I want it to be. Okay. I'm about to start telling you what crosscat means. Okay, so now write a function, crosscat, that will take 4 strings and print out the concatenation of the first and the third string, and then on a new line, the concatenation of the second and the fourth string. But you're not allowed to use the print function. You are not allowed to write print anywhere within crosscat. What? Well, what does it just say here? All I'm saying is you can't use print. You cannot write print within crosscat. That's all I'm saying. But I give you a hint. You can use catster, which of course has a print. We just wrote it. So I'm going to give you a minute or two to think on this one. If this is easy for you, great. If this is difficult for you, you're normal. You're really normal at this stage. But think of this as a big hint. And definitely use catster somehow. And let me remind you what catster does. Catster is simply a function that'll take any 2 strings and print out the concatenation of any 2 arbitrary strings. Remember that. What I'm going to do right now is write a solution to this problem that cheats. I'm going to use print. Sometimes, when in doubt, if you've got constraints like this, if you know how to solve it without the constraints, do that and then see what you can do. So all I would have to do is like 1, 3 equals a word plus b c word. Because though that's the first and the third. And then I want 2, 4 to be b word plus d word. And then I guess print so my cheating solution worked, but of course, this is no good. Raise your hand if you got it already. Okay, that's good. That's very good. Keep working though. I'll give you a minute or so. See if you can get this one working. What's up?
Would there be any difference in that function than does what was written there if we move print 1, 3 below?
It won't matter. Sure, things will technically happen in a different order, but that order isn't going to matter here. Like you mean if this was like here? Yeah. It's the same. What's up?
So I managed to do it, but then was editing my cat string code, but now it's not doing it. It's using the old cat string.
Yeah, you have to rerun your cat string block.
I did. They're all in the same block. They all show a run, but it's not.
Then you did something wrong. I don't know.
I can't figure it out.
Make sure you got the right name. If you change the name, that might mess it up. Okay, raise your hand now if you're done. Really high, I want to see. Okay, maybe a quarter of the class. Okay. So now let's do it together. But I'm going to warn you. If after my explanation it still doesn't quite click, that's fine. But I'm going to strongly encourage you to take the time to think on this one later. And there's a YouTube video to help you. Because this is tricky, but it's important to understand. So this clearly works, but I'm cheating. Why is it working? Well, what I'm doing is I'm concatenating the A word and the C word, so the first and the third, and printing it out. And then I'm concatenating B word and D word, and then printing that concatenation out. Right? That's it. That's all I'm doing here. But of course, the trick is you can't use print. But I've got some really good news for you. What if I tell you, I got a function for you that takes any two strings, concatenates them, and prints them out? If that's the case, I don't even need to worry about, in the function that I'm writing right now, I don't need to worry about concatenating the strings in my code that I'm writing right now. I don't need to worry about printing it out, because I could just ask another function to do all that work for me. What is this doing? It's concatenating this string, and printing it out. Well, what happens if I do a word, and B word. And then I don't need this anymore. I replace these two lines of code, but for the first one, with the function call that does the exact same thing as those two lines of code. That should be C word, B word, and then D word. Okay, I'm going to rerun this one. Nope. Now I'm going to. Okay, so I rewrote crosscat. I got rid of the prints. But, here, let me delete this here. If I hit run, if I change the function, but it still operates the way I want it to, I'm happy, right? Run. Still works. Why? Well, let's follow this through. And you know what? I'm going to change the name of these because I don't want you to think that the fact that this is a word and this is a word, the fact that they match, does not matter at all. It was just a coincidence. Maybe if I do let's do word 1, word 2, word 3, word 4. What? There. Okay, now I'm happier because the parameter names don't align. Because sometimes seeing that they match, you might think, oh, does that matter? It doesn't. So what's happening? Okay, let's follow this through. When in doubt, follow the code. That's the only secret. Do what the code says. Make no assumptions about any of those lines of code. What are we doing? Okay, let's call crosscat. I'm going to give it first, second, third, fourth, those strings. So we jump up to here. Word 1 is now equal to first. Word 2 is equal to the string second. Word 3 is equal to the string what? Now more people. Word 4? Exactly. So then I go down here and this line of code's running. Catster, word 1 and word 3. Well, what's word 1? What's word 3? So I jump up to catster. The variable a word is now what? Everybody yell first. B word is what? Say third. Someone over here is loud and it feels like everyone's waiting for them to speak first. So then what do I do with first and third? Concatenate them, put it in the string, print out that string. This will print out the concatenation of a word and b word, which happens to be first and third. This function finishes, we go here, line 2 is done. Because line 2 called another function, the other function did the calculation, and then we jump back to this line. We go down here. Catster on word 2 and 4. So when I get to catster this time, what value does a word have? B word. The lack of energy here is concerning me. Because I don't know if it means that it's just apathy or if it's like you don't understand. If you're concerned about how do you know which variables are what, just follow the pattern. It lines up. First, like the one that comes here will be the one that aligns here. The one that goes here is there. It just matches accordingly. And then word 2 and like 1 and 3, so this one and this one would become a word and b word in that first line, and so on and so on and so on. Anyways, we get to catster again for second and fourth, concatenate it, save it, print out the saved string, return, we're done, we're done, we're done. Follow the code when in doubt. I'm also going to give a big warning. There's a lot of people in the class that keep telling me that they've got all this experience programming. And that's great. But it's remarkably typical for those people to do very poorly in this course. Because a lot of people, when they have that experience, they have a lot of gaps. And the things that I want to teach you, if you are self-taught, great, but there might be some gaps. Or maybe you had a high school teacher, but there can be some gaps there. Usually what'll happen is people that know what they're doing show up and be like, oh, I know what's going on. And then 2 weeks later, they realize, oh shit, what the hell's going on now? And then it's too late. So if that person is you and you have a lot of experience, careful. It might come out and bite you. Okay. If you're still really stuck with this, watch the video and think about it later. If you're really, really, really stuck, and I'm not joking, one of the best friends, in fact, near the end of this semester, I think, or at the very least at the beginning of next semester, at every lab you have to have a sheet of paper and a pencil. Draw what's happening. I'm not being silly. One of the best investments I got during my undergrad in computer science is buying a whiteboard. It changed my life. You just draw everything. It's perfect. And you don't have to be a good artist. All right, so execution, flow, well, this is like what I was talking about before. I have this function here called do stuff. It takes 2 parameters, it does some calculations, and then it returns C. But that first 1, 2, 3, 4, 5 lines of code, when Python reads those 5 lines of code, it's not doing any number crunching yet. It's just going, oh, they're defining a function. I'll remember this. So then we get down to line 7, x equals 2. Oh, okay, well now x has 2, y is 3. Call do stuff on x and y, which is 2 and 3. Jump into line 1. A is now what x is, which is 2. B is now what y is, which is 3. Do all the calculation, return the result, save the result in Z, and then print out Z, print out where am I? Follow the lines of code. What does it say? What does it mean? So Python reads this and goes, all right, great. But it didn't do any like calculations yet. Here is where stuff actually starts running. On this line right here, Python will like jump up to this function and start executing the code in this function. And then once it's done, it goes back to this line of code. So it's kind of like that, right? But I mean, here it was a function in a function, but it's the same idea. I need to calculate g of x, but I need to go here, and then I go, oh, it's x squared, which I guess is, in my case, that's 4. This turns into the 4, and then I can carry on. So it's a way we can like jump to other parts of the code. Yeah. Now, you may have noticed, and those of you that were in lab yesterday, you absolutely should notice, this, return. That might look very new to you. Warning. Return does not work at all like print. You might think it does not. Colab unfortunately kind of tricks you into thinking it does. But I'm telling you right now, it does not work that way. Return isn't like a print. And I'll show you where that confusion can come in a moment. So, sometimes when you call a function, it does some number crunching, and you want the result back. In the do stuff example, it does all these calculations, which is critically important for my nuclear power plant, right? I need the result of that function though, just like this. When I calculate g of x of 2, well that's 4, I need to take the result of that function and use it somewhere else, namely in f of x. So I want that result back, and I want to store it later for more calculations. Like maybe I wanted to print z plus 1, where z is whatever the result of this is, plus 1. I want to save it. printing stuff out isn't that helpful on the computer side of things. Like if you just print it out and you're like, okay, we'll use the result to do something, and if you only printed it out but you don't have it stored anywhere, it's kind of useless. Maybe your program is just print out a value to the user, fine. But if you want to save the result, we're going to use return. So here, this function does a whole bunch of calculations, and on this line right here, I said C equals whatever. And for whatever reason, I want this function to give me back that value that C has for the arbitrary inputs that I give it. So return gives you back a value. If you open up Collaborate right now and say 1 plus 1, it gives you the value too. If I call the function do stuff and type in 2 and 2, it looks like it's going to give me back the value 16. But the trouble is, you'll notice that I had to write print around do stuff. And we can use the result of do stuff to do other calculations, like print out do stuff plus whatever do stuff of 4 and 4 is. I guess the result's 40. We can do this now. So, let's def density of, I don't know, mass vol is it mass by volume or volume by, probably mass, right? Mass. Okay. I wrote two functions that look remarkably similar, right? The only difference is, well, the name, and the fact that one returns a value and the other one prints the value out. So, if I want to calculate the density of something, okay, so let's say of 100 by 10, I don't know. Perfect, it's 10. Right? This should be fairly clear, right? Call this function, do this calculation, give me back the result, put it in density, print it out. That's what happens. If I change this to that, well, now it just does the different calculation based on the values I passed to the function. Let's see what happens now if I just change this out for density sad. Okay, watch closely. What do we see that's different? It prints out none. It printed out the result 1000, but it also prints out none. You know what? Let's, for whatever reason, I'm gonna go back to the regular density. I'm gonna hit run. I wanna calculate the density, and for whatever reason, I want to add 22 to it. Don't ask why, I just do. It's important for my calculation. Because we can. So I hit run, and yeah, it's fine. Why? Well, because density did the calculation, it gave us 10,000, stored it in the density, then I took the value of the density, which was 10,000, added 22, that's 10,022, printed it out. Great. Let's change it back to sad now. If I hit run, think about what you expect to see happen. Most of you will probably be wrong, and that's fine because you've never seen this before. Well, it printed out, well, I guess it's 10, yeah, it printed out 10,000, which is the density. But then now it says unsupported operands for plus, none type, and int. The problem we have here is the regular density returned a result that I could store in a variable. This function returns nothing. There's nothing being returned. And there's a very special value in Python called none. If you're used to other programming languages, you may have heard null or nil. In Python, we call it none. So I'm going to go back to just this. I'm going to print out density and type. No. The density. So now here I say the density. We see the 10,000, but then it prints out none and none type. So the print that prints this out, let's follow the code. Line 1 says the density equals this. Oh, it's a function call. So let's jump up to the function. Mass becomes 100,000, volume is 10. Do the division, save it in D, and print out D. That's this. It's this print in the function that prints out the 10,000. But I stored what this function returned in the variable the density. But the trouble is that function didn't return anything. It returned nothing. And none is a very, 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 very special value. It even has its own type. We've seen integers, we've seen floats, we've seen strings. Soon we'll see Booleans. Booleans are a neat type. A Boolean is just a type that can only ever have one of two values, true or false. Okay? 0 or 1. But we also have a type called none type. And the cool thing about the none type is, it's this thing, it's a type that can only ever have one value. Nothing. None. It's a special value that we use in a variety of places that you'll become more familiar with as we go. But the point is, this function doesn't return anything, so I can't do anything interesting with it. Here's where the confusion comes. I'm going to go back to density. Right? I'm going to hit run. And now it says, well, the density is 10,000 and its class is float, which is correct. It's just this print that's running because the regular density has no print statement in it, or print function in it. Well, what happens if well, I mean, first of all, let's get rid of the type thing. Okay, cool. It's just printing out the density. I know it's going to be a float. I don't have to print out the type. But what's going to happen if I get rid of this line of code here and I hit run? And you know what? I'm not even going to save the result anywhere. I'm just going to call the function density 100,010. Here's where people get confused. At no point did I say print out the result, did I? The function used a return. I never wrote print anywhere, I mean, except here, but this function's not being called. Yet it printed out the result. That's only the consequence of Colab basically letting you know that, well, this function returned a value and you didn't do anything with it. There's this like random lost value floating in space. So Colab goes here. It didn't print it out, it showed it to you. There's a difference. It seems like they're the same thing, but there is a difference. If I save this somewhere, it doesn't print it out because that value is not lost anymore. I shoved it into the variable called D. And if you're like this and you're depending on the fact that Colab does this, and you submit an assignment or something, and we run it as a script, I'm not seeing any output in the script. This is only a Colab or like an interpreter thing. In fact, let's see what happens if I do this. I'm going to call it a bunch of times, maybe with some different values. One, two, three, four, five. I called it 5 times, but what do we see there? Only one. Only the answer for the last one. Python will only, or Colab will only do this thing where where it shows you that lost value if it's the last line. Yeah. Oh, I thought you were having it. Gotcha. If you want to print something, use print. If you want your function to give you back something, use return. Huge difference. And whenever, like at this stage, all I'm doing is saying, do this calculation, return the result, and print out the result. So you're saying, like, but what's the point? Just print it out in the function. You're right, but most of the time, like once we get past this first like week or two, we're not just going to be doing the calculation, printing out the result. We're going to be doing the calculation, using the result to do more calculations, and so on and so on and so on. And then at the end of all those calculations, maybe I print something out. So big difference. Can't emphasize it enough. And don't be surprised if this bites you. Here's what I want you to do. If you ever see none type now, I want you to think, oh, Dr. Hughes was talking about that funny return print thing. Make your brain go there, and that might help you debug. All right. So we're going to skip this activity because I just ranted about it. Instead of no stuff and do stuff, I did density and density sad. It's the same thing. And I'm going to skip this one too. Composition, there's nothing stopping us from doing something like this. Because do stuff 2 and 2 will give me back a value. And do stuff 2 and 2 on that side will also give me back a value. It gets evaluated to a value. Which then is giving me I can now use do stuff, the outside one, on the value that do stuff 2 gives me in there. Like I can do this. I don't recommend it in most cases. You can. This becomes a little bit more difficult to read. Maybe I strongly recommend doing like one calculation, saving it to a variable with a good name so someone comes along like me, you're writing your code and you say I'm stuck, and I read the variables and I know what you're doing because your variables are well worded and well named and everything, great. If you do something like this, I'm going to be like, what the heck? Like, what are you doing? And it's going to be harder to like decode what on earth you're trying to do. Verbose code is good code. Yeah. Maybe do these on your own. Variable scope. If you define a function here like this, C, or a variable within a function like this, C, it only exists inside that function. For example, here, I'm going to restart my runtime because I think I did use D at one point in time. Yes. So if I call density sad, okay, great. But look, I assigned a value to D. Well, let's print out D. D is not defined. D only temporarily existed inside that function. And as soon as that function finished doing its calculation, D disappears. Yeah?
So if I wanted, like I know I shouldn't, but I could have 2 variables with the same name, one in a function and one...
Yeah, you absolutely could.
Yeah.
But be careful, but yes, you could. Yeah. And then you're like, but then you may beg, this begs the question, but what happens if I want the D? I want the variable named D. Well, what do I do instead? Everybody say return. Exactly. If I want that value out of the function, return it from the function. It's stuck in, D is left in that function as a variable. Anyways. All right. See you later.